Hello, welcome back to the next video in my series where I catalogue my attempts at creating my very first Mega Drive game using SGDK. This is actually the third attempt at recording this video. The first attempt I actually implemented a few features, shuffled around the menus and the state system a little bit, discovered I lost the mic audio. So I re-recorded it a couple of hours ago, and just as I went to edit I discovered I'd lost the audio. So this is the third video, and if this one doesn't work out, I'll be annoyed. So this is a bit of a progress video because, as I mentioned, the first attempt at this, I had implemented some things and I talked through them and lost it, so I'll just show what we've got in this video. So to do that, let's quickly jump over to the emulator and have a look at how the ROM looks at the moment. So we've got our intro screen. Now this is either going to wait 10 seconds or I can press the start button to interrupt it. So we'll count it down. There we go, and it jumps through to our main menu, which may look a little different from the last video where I discussed states and implemented the basic menu. Go and check that out up here if you'd like. Credits and instruction screens haven't changed, they're still placeholders really. What's interesting is when we select play now, we'll be taken to a level select screen. Here we can use a cursor to select a level based on these, well, these graphics are in the background plane, they're not sprites, and I refer to them in code in particular as level name graphics. If I hover over them, we get a very simple horizontal line scrolling effect. Now if I press A, takes us to the new gameplay state, which is what we're seeing here. This sidebar is actually implemented as the window plane, which is a subplane of background plane A. That's 10 tiles wide and fills up the full screen. I actually asked ChatGPT to help out with the basic border image, and it did a pretty good job of that straight away. Certainly good enough for a placeholder. And then I actually used a sprite to touch it up a little and add these level, wave, and score labels. The numbers that you see there are a separate custom number font with just the 0 to 9 glyphs that I made out of a tile set. We'll have a look at that in a moment. And it's basically counting up through 9 waves, a couple seconds each, before it loops back to the menu select. Sorry, the level select. And just to show you, map 2 is also a little different. There we go, nothing terribly exciting. At the moment I can also press start to escape out of that, that's just how the code is. And I've got this weird artifact where the menu was, it's still obstructing the plane. I'm not sure what's happening there. We'll quickly take a look over at A-Sprite to have a look at the sprites that I just mentioned. So here we have the background graphic for the window subplane, where I've added in the level sprites. And on the other tab, we've just got a little tile set of 10 glyphs for 0 to 9, and they're 2 by 2 tiles each. If I turn on the grid, we can see, there we have it. Another thing I have done since the last video, for my own benefit as well as to show things a little more clearly, hopefully, I've created this state diagram using an online tool called draw.io. You can use draw.io online for free, which is what I've done here. You can also get desktop applications for Windows, Mac, and Linux as well, which I also use. We're just showing off the state transitions, where power on is what you'd expect it to be. It runs through the intro where we see the Mega Tower stylized text, and we wait for 10 seconds or start before we move to the next state, where we have our main menu screen and we can go to credits or how to, pressing start to go back to the main menu, and our level select screen. I think press B might be a typo, that might still be start. It doesn't really matter, but there is a button to go back to the main menu. Or if you actually hover over one of the level name graphics and press A, you go down to the gameplay screen. Let's have a look at what the code is looking like now. So we're looking at our main.c file, and it's still quite sparse. It really is just breaking out to the game states. I think recent additions are the level select screen and the gameplay screen. That's essentially all that's doing, aside from initializing our sprite engine and joystick engine. We've still got our global variable for the current game state. The next point of interest that we might look at is going to be the level select screen. You might notice that there's no resources.h. What I've actually done is, if you scroll up here, we've got our resources directory in the project navigation window. And there's different folders where I'm trying to keep the relevant resources, but the resource res files are still in the res directory itself. And for each res file, say here level2.res, we still get a level2.h. Similar to how you want to break up your code in modules, I figure we want to keep our resources as organized and compartmentalized as possible to help keep things a little neater. But in our level select screen code, we'll narrow this a little. We have a cursor sprite and X and Y position for that. That's the little yellow arrow that we move around with the D-pad. There are a couple data structures and array for the level name graphics. Now these are simply tracking the X and Y positions of those graphics and their width and height. Now width and height are measured in pixels or scan lines, which is especially relevant for the height, as we'll see in a moment. And then we also have a list of Then here we have a list of level data structures, which are defined in the new gameplay screen header file, which I'll bring over to the right side of my IDE. And as we can see here, that currently just contains a map, palette, tile set, and the level number. And these three items here will line up with the resources that we'll find in our res file. So each level will have a palette, a tile set, and a map. But back in level select screen.c file, that list essentially marries up one entry for each of the levels, and currently I've just got 3 levels essentially as a placeholder again. Selected level is -1 to indicate that no valid level has been selected, so the cursor is not on a section of the screen which has a level name graphic underneath it. The joystick handler is simply responding to pressing the start button to go back to the main menu and pressing button A while we have a selected level equal to 0 or higher, at which point it will load this active level variable, which comes from the gameplay screen C file, and changes the current game state global variable so that we will break out of our loop and jump across to the gameplay screen. There's a couple variables here around the horizontal scrolling effects, that little shimmer that you saw. We'll jump over to that. This shimmer effect that we're seeing on map 2, that is horizontal line scrolling, and we're only scrolling on the horizontal lines that make up that image for map 2. Initialize level data is just initializing that array for all of our game levels, again referencing entries out of the resources files. There's a bunch of code here for horizontal shimmer. If folks are interested in a greater explanation of how I've implemented that horizontal scroll effect, it's fairly straightforward, but do drop a comment to let me know that you'd want a slightly more deep depth dive into that. It's on my hand wavy roadmap that I'd like to do a thorough tutorial video at some point regarding the different scroll options that SGDK and the Mega Drive hardware does provide. But essentially we have an array called line scroll values, which is as many lines in length as we have pixels of height for our level name graphics, because a pixel is basically a scan line in the vertical direction. So the initialize scroll offsets just goes through, and every even line we set the scroll value in one direction, and the odd lines we set it in the other. There's also a parallel array to go with that to indicate whether a particular line is in the process of scrolling left or not, and that just affects the calculations that we make later on. Reset scroll offsets is used to set the line scroll values array to 0 for all lines, so that then they can be applied to the VDP registers, and that will essentially take whatever our shimmer is doing and set it back to a normal graphic, which we will do when we detect that the cursor is no longer over a level name graphic. Apply H-line scroll is essentially running through the array of line scrolling values, and depending on whether we're going left or we're going right, we will adjust the line scroll value for that line and check to see if it's gone far enough, which is our H scroll shift amount. That's how many pixels off center we're going before we bounce back the other direction, basically. And we're only doing 1 in what I've got happening at the moment. And then after it's updated all the entries in the array, we use set horizontal scroll line on the background plane with our start line, which will be the Y coordinate of the level name graphic that we've determined the cursor is over, and it will apply the line scroll values array, and we will get the effect. Check cursor hover is called by a function that we will look at in a moment, which is just controlling the D-pad and detecting movement there, updating the cursor position, and only calls this if we detected that the cursor position was moved, because there's a bit of an arithmetic in here that if we don't need to call it, we don't need to call it. But all that's really doing is going through our list of the level name graphics for map 1, map 2, map 3, and just determining based on the cursor position and the dimensions of that level name graphic whether we have the cursor over the top of it or not. And if so, we use the selected level that goes with that. We set match found to true, and we make a note of that level name graphics Y position as our scrolling, as the start line for the horizontal scroll effect. Once again, I apologize if my tutorial approach, is not great, but if you want, again, if you want me to try and do better on the scrolling or anything that I bring up in this video, be sure to drop a comment. This block of code here is determining that if the match isn't found, so we've determined that the cursor is not over any of our level name graphics, then we need to make sure that we indicate that the selected level, there is no valid level selection, so we set it back to -1, and we mark the horizontal scroll active flag as false. We'll also reset the scroll offset, so if anything was in the middle of scrolling, it's just set back to 0, and set horizontal scroll line to apply that to the VDP, and update our debug text. Check D-pad is it's essentially just polling the D-pad on the joystick, moving the cursor around as need be. If there was a change, we mark that with changed equals true, and only if changed was true do we update the sprite position for the cursor, and then run our code to check to see if the cursor is hovering over the map 1, map 2, or map 3 graphic. The level select screen is the main function for the level select screen. Wow, it does what it says on the tin. Line scroll delay, we use that later on just to put a little bit of a delay between the actual application of the shimmer effect to slow it down as much as we'd like, or speed it up. Current tile index, I'll mention that in just a moment, but that's essentially keeping track of the next index that we can use to load a tile into the VDP's VRAM without clobbering any other tiles and corrupting our graphics. We'll see that being used a little bit later. Initialize level data is essentially just setting up the level data array that we'll use. Initialize scroll offsets, setting our line offset values to all zeros. Enabling horizontal line scrolling mode in the VDP. Then we're just setting up the cursor sprite, setting up the final color in palette 0 to make sure that any text we try and draw is going to be white. Install the joystick handler and clear the screen. Clear all VDP planes is a helper function I wrote myself. This section here, we're essentially loading the map 1, map 2, map 3 level name graphics and drawing them onto background plane B. And here we see the current tile index. So in the beginning, when we enter this loop, we set that to tile user index. And the first time we want to use it is when we go to draw the image for map 1 select text. We set that, and then once we're done, we update it with the number of tiles that was in the image for the map 1 select text. Then we'll use we can use current tile index as we load up number 2 and number 3, and we won't clobber any of our graphic tiles, so our graphics will look as we expect. Then we just enter the main state loop for this screen, where we're just checking the D-pad, updating sprites, updating the line scroll delay, and calling the function to apply the horizontal line scroll after the delay has expired, and we do our v-blank wait. You'll notice at the bottom here, we've got a little bit of code. This is essentially cleanup for when our main state loop here exits. And all this is doing is releasing the resources for the cursor sprite, and that will also make it invisible. But we must remember that we still need to call sprite update, just to be sure that we tie up all those loose ends before we leave the level select screen. We call the v-blank process one more time. Okay, so now on the screen, we're back up to our joystick handling function for the level select screen. If we press button A and we have a valid selected level value, i.e. 0 or higher, we'll set the active level variable from the gameplay screen code to whichever entry from the array matches the selected level that we have. Then we change the game state to the gameplay screen, which means that we'll then transition over to the code in gameplay screen.c. Currently there's not much to it, it's still very much a placeholder. All we have at the moment in terms of button handling is if you press the start button, it will set the game state back to the main menu, and that's where you'll go. We've got the variable which indicates our active level. Our active level is a level data structure which holds the map, the palette, and the tile set, which line up with resources for palette, tile set, and map in our resource file. Window text buffer is just a small little buffer that was from my first attempts at printing some status stuff onto the window display. Gameplay screen function is the main event, so to speak, for the gameplay. And this is where the meat of the game will actually be implemented. As we saw previously, there's this pattern where I use set current tile index to tile user index, and I'm resetting it back to that constant to just assume that I'm going to take full control over the VDP and clobber anything that's there to set up my graphics for this screen as I see fit. Now, game window tile offset is essentially a way for me to keep track of where this menu here from the gameplay screen, it allows me to keep track of where those tiles were loaded into VRAM, which will become useful when I want to draw these custom font tiles as background tiles of the window rather than as sprites. But back to what gameplay screen does. We call clear all VDP planes to make sure that the screen is clear. Current tile index is now assigned to the value of initialize game window, which also receives current tile index, and it takes the address of the game window tile offset. Now, this is a pattern that you might see in C code where we have what we call in parameters versus out parameters. Because we pass this value in the first one in with the expectation it's used and that's it, without being modified, hopefully, we call that an in parameter. Now, because we've passed the address or our pointer to game window tile offset, the code within initialize game window can actually write to that address in memory, and it's simply a way of essentially returning more than one value from a C function. People that come from Python might be familiar with more than one return value. This is how you achieve such a thing in C. It's a little bit different, but it does get the job done. We'll quickly take a detour and have a quick look at initialize game window. So my thinking here is that I have game window.c, and the idea is all of the code behind this window on the gameplay screen, I want to try and compartmentalize that into one place as best as possible. So initialize game window, that takes the first parameter of VRAM tiles offset, which says, hey, this is the next place you can load any graphical tiles into VRAM memory without corrupting anything. Once you've loaded that, I want you to write that new offset out into this variable as well. We'll see why in a sec. So this is us setting up the window plane. I might go into that again in a greater detail in a video. Again, drop a comment if you want to hear about that. But we essentially have to tell the VDP which vertical and horizontal positions, how that subplane, the window subplane, how that is carved out of plane A, essentially. So here we are making a direct copy of the window tiles offset from the value we were passed in. You could argue that this code could be done before we call initialize game window. That's how I've done it here. And then we draw the background game window image into the window subplane, making sure that we update our value for VRAM tiles offset. Well, we don't update that one. We add the number of tiles in our window background image to it and then return that. And that will allow the next piece of code that wants to load tiles into the VRAM to, again, not corrupt what's already in there. And destroy game window does essentially what it says on the tin. Okay, we'll go back to gameplay screen.c. We've initialized our game window backdrop, current tile index, and in it the number sprites. Now that's essentially a little helper function I have in a module called numbersprites.c. The name is actually a bit misleading because it's not sprites, it's background tiles. And the reason I want the numbers to not be sprites is because if I make them sprites, I would have the benefit of being able to put them exactly anywhere pixel perfect on the display and having transparency. But if I use them as sprites, then that's going to eat into the number of sprites that I can have on screen and also on a horizontal line. So trying to keep things as background tiles where possible is better for that regard. And that's what I've tried to do with this numbers thing. So what we're implementing here is essentially a custom font that only has 10 characters in it, the numbers 0 through 9. But that's what we're aiming for. And again, if you do want to see me go into this in a bit more detail, which I think would be an interesting topic, hit me up in the comments and I'll know that people are interested and I'll make an effort to do a decent video on that. But all we're essentially doing is making a note of getting our input to tell us where the next tile index is, and we call VDP load tile set to load up our numbers tile set. That is 10 2x2 collections of tiles. After we've initially loaded that, we do make a note of number tiles index in this variable up here, which is local to the number sprites module. And that's useful because when we use this function on put number tile, it will want to know where the tile set for the numbers that we want to use lives in the VRAM. So we need to make a separate note of that. And then we return an updated value for where we started loading our tiles, plus the number of tiles that we loaded in. So again, the next loader of tiles into VRAM doesn't clobber things. And put number tile simply uses the set tile map ex call to take a portion of a tile map, or tile set, sorry. Oh, it is using a tile map. Taking a portion of a tile map, XY, width and height, and putting that at XY on a specific plane. This one is actually hard-coded to go into the window plane. That could be a parameter. That's probably a future improvement. But it essentially takes an index into our number array and gets the relevant set of tiles. And that's what we use behind this level and wave counter number sprite. Just wanted something a little bit more interesting than the default font that SGDK gives you. So back to our gameplay screen function, we install our joystick handler, which is largely doing nothing at the moment. Set up the palette from the active level that we made a note of when we left the level select screen. Load the tile set for that and load the map. This use of current tile index is currently unused, so that could probably be removed. Actually, yes, we will remove that so that it's not confusing and getting in the way. Then when you want your map to appear, you actually need to call the map scroll to function. Now, this chunk of code here was me trying to deal with an issue. So when you put background tiles on the window subplane, if there's a transparent pixel, it won't actually act as transparent. It'll basically cut a hole through it and you'll see what's underneath it on plane B. So this was me thinking, well, if I take the status window graphic and redraw it on plane B underneath where it would sit on the window plane, hopefully any holes cut in that, say around my numbers, would effectively be transparent and wouldn't cut a black square. But if we look at the window display, we've got black squares around that. If there is a better way to do that, I haven't worked it out yet. If you know, feel free to drop a comment. Let everybody know. Okay, and put number tile. That's just putting the level number down. And wave number, all we're doing so far is just counting up to 9 waves. We're waiting 5 times 60 frames for each one. Once we get over the 9th wave number, we set the game state back to the level select and we'll drop back. So that's all we have on the gameplay screen at the moment. We'll quickly jump back over and have a look at that again. So I just created these maps in Tile D. Here we have Tile D. I've got a custom tile set which I created in Sprite. It's fantastic artwork, I know. Now you may notice that there's this 10 tile wide blank space on the map. I haven't worked out yet how to use a map resource, draw that to the screen without it wrapping around. So the first time I did this, my map was 30 pixels by 28, which is the colored area here. And it actually wrapped around 10 tiles, and that wasn't really what I wanted. So I just opted to put blank tiles where the window graphic would be, and that seems to work out and line up just fine. The other thing we have here that I haven't worked out yet is there's this no place layer. If you look up here, and that essentially has, I've inserted tiles, which is this red tile, which is supposed to be special to indicate that you can't place things there. So the idea being that darker terrain, you can't place towers. The lighter terrain is supposed to be where enemies go, and you can't place towers there. And then the middle color, I guess, that is where the player will be able to place their towers. And the idea being that each of these red squares will be a no place sort of flag in a collision array. Once again, I'm pretty sure that Tile D has a suitable way to do this with minimal pain. I, at the time of recording, am not entirely sure how to do that. However, if need be, I'm a reasonably decent Python programmer, and this would be a pretty straightforward script to create. If we jump over to this text editor, here we have the XML file, which is our level TMX. If you see up here, we've got test map simple paths L2.tmx. We've got a layer for all of our actual tile indexes. And then there's this object group, which looks like that's our no place layer. It'd be fairly straightforward to craft a simple Python script to parse the XML, pull out the X and Y coordinates for each entry here, and basically just put it into a C array saying, hey, no placement available. And that would actually be a prime candidate for something that I could ask ChatGPT or GitHub Copilot to craft that script. Probably 5 or 10 minutes thinking of a decent prompt, and I reckon that would give us something usable, so we'll keep an eye out for that. Again, if you do know the better way to export such things as collision arrays from TileD, either drop a comment or a link to a video which explains it cleanly, that'd be great. So I think that's probably a good place to wrap this video up. I've demonstrated the current state of affairs. I think that the next thing we want to do is, with this gameplay screen, we'll switch over to the emulator. The next step will probably be put tower sprites on a cursor and have them get the collision information in, and sort of have just the basics of being able to place towers where we can place towers. That's probably the next step before I worry about moving mobs. And then I'll probably have the enemies moving and do radius checks to determine when towers are within range and should be able to shoot an enemy. But this is probably a good place to wrap that video up. Again, if there's anything that you'd like me to go into further detail, be sure to drop a comment and let me know. I know I've said that a lot, but this is new and I'm not really sure entirely what people want to see. But I hope you did find that either entertaining or informative in some way. And look, no one likes to hear it, but if you were to like, share and comment, subscribe, and all the YouTubey things, I don't want to make a habit of that on this channel. But if you were to do that, that would really help me out a lot, and it's good to see that people actually give a damn. Anyway, folks, we'll see you in the next one.